Welcome back, guys. This is question 5.65 and 5.66, and the statement of the 5.65 is an automobile manufacturer is concerned about a fault in the braking mechanism of a particular model. The fault can, on rare occasions, can cause a catastrophe at high speed. The distribution of the number of cars per year that will experience the catastrophe is a Poisson random variable with lambda equal to 5. Okay, so on the basis of it, what is the probability that at most 3 cars per year will experience a catastrophe, and B, what is the probability that more than 1 car per year will experience a catastrophe. Okay, so on the basis of this data provided, let us solve this question. Lambda here we have is 5. Okay, and in part B of it, what do we want to find out? What is the probability that at most 3 cars per year will experience a catastrophe? Means I want to find out the probability that x is less than or equal to 3, means at most 3 cars, means all the other values will be less than this one. We want to find out this. And in part B of it, what is the probability that more than 1 car per year will experience a catastrophe, means the probability that x is greater than 1. Both of these probabilities we want to find out. Okay, so first let me solve probability that x is less than or equal to 3. In solving this question, okay, this one, we know that here the formula in the table we have is what? That is the probability that x is less than or equal to small x. Okay, we have something like this one, and we have some value of lambda. On the basis of that lambda value, on the basis of that x value, we can very easily find out the probability of that item. Okay, so here we know the value of small x, we know the value of lambda, which is 5. So let us move to the probability table. Okay, so here this is the probability table, and here let us move to the lambda equal to what? Lambda equal to 5. So this is the lambda equal to 5, and also the value of x, which is what? Which is 3. So this is the value for it, and this is here. Okay, so we know that the value of it is 0.2650. So it would be 0.2650, and that is what? That is basically the solution of part A of my question. In part B, as this is not in the form of 8, so therefore it can also be written as what? It can be written as 1 minus probability that x is less than or equal to 1. Okay, because here all the values are greater than 1. Here I can write it like this one. So now if I know the value of it, now I know that this is in the form of it. Now you know the value of x, I know the value of lambda, which is a similar one. So by using the probability table, I can find out this value. Okay, so let us move to the probability table, where the value of lambda is still 5 while the value of x is 1. So here it is, so that is 0.0404. So 0.0404. okay, once I will subtract it from 1, it would be 0.9596, and that is what? That is basically the solution of part B of my question. This is the part A of my question, and all of this is basically the solution of question 5.65. okay, so that is what? That is basically the solution of question 5.65. So similarly, the question 5.66 is the similar one, and the statement of that question is changes in airport procedures require considerable planning. Arrival rates of aircrafts are important factors that must be taken into account. Suppose small aircraft arrives at a certain airport according to a Poisson process at the rate of 6 per hour. Okay, so lambda is given. Thus the Poisson parameter for the arrivals over a period of r is mu is equal to 60. Okay, means here the value of, if this is a solution here, okay, so here lambda is what? Lambda is 6. So on the basis of it, part A of it is what is the probability that exactly 4 small aircrafts arrive during a 1 hour period. Okay, so part A of it is what is the probability that x is equal to 4 okay, because exactly 4 arrived during 1 hour period. So therefore this lambda will remain the same. And part B, what is the probability that at least 4 arrived during a 1 hour period, okay, means, so this is part B, and at least 4 arrive means that all the other values will be greater than 4. So here the probability of x would be greater or equal to 4, okay. So this is what we have here, but now this is greater or equal to 4. In these type of question, what we can do, we can use the Poisson formula as well, but here it would be feasible for you to use the Poisson table, and that would be in the form of this formula. So therefore I have to convert it into the notation which will be less than or equal to the value of x. So therefore in order to transform it into this formula, what I can write here, I can write it like 1 minus probability that x is now less than or equal to 3. Okay, so these are the values which are now less than this 4. So therefore it will be less than or equal to 3. So here this is the thing which we will find out for part B of my question. Okay, so now let us solve it. Okay, for solving it, let me use this color. So here, in order to solve it, I have to use the formula because it is not in the form of this. So therefore this is a single value. So therefore the formula for it is L exponential of minus lambda of x divided by x factorial. Okay, let me put their values. So it would be exponential of minus 6, which is the value of lambda. Okay, similarly lambda raised to the power 4 divided by the 4 factorial. Okay, solving it, you will get what? You will get the answer of part A of my question. Okay, similarly, so now here, in order to find the probability that x is greater or equal to 4, because the values are here at least 4. Okay, so 4 here, 1 minus probability that x is less than or equal to 3, as this formula is now according to this one. So therefore in order to solve it, what do we have to do? Here the value of x is 3 while the value of lambda is 6. So therefore now I can use the Poisson distribution table, because now I have all of them in the form of this table. So let us move to the Poisson distribution table where the value of lambda is 6 and the value of x is 3. So let us move to that. So the value of lambda is 6 here, and the value of x, which is 3, is here. Okay, because all of this is now in the form, let me show you, in the form of this formula. Okay, where this is what we have transformed it into. Okay, so therefore now in order to find this value, this would be 0.1512. So let me write it 0.1 minus 0.1512. Okay, so if I will subtract the values from it, we will get the answer from it. Okay, so that is what, that is basically the solution of what, this is the solution of part A of my question, and now similarly the solution of part B of my question is this one. Okay, in order to solve the part C of my question, we will do it in our upcoming video. Also you can practice it yourself. Okay, so that's it for today, in which we have discussed the Poisson probability distribution, where to use the Poisson table and where to use the Poisson formula, and the table is basically the Poisson CDF table. Okay, so that's it for today. If you have any question, you can ask me in the comment box. See you soon.